Hi guys. And today I'm going to talk about the third line of defense, the specific immunity. Just to recap the last two videos that I took, I went over the non-specific or innate forms of immunity. And remember that the innate, those are the physical barriers, the chemical barriers. They get the first interaction with those pathogens. And then the specific immunity is only used if the first and second line are not working, and this specific or adaptive immunity comes into play. And specific immunity is actually pretty cool with how it works. Okay, so again, this is the third line of defense. So if you look at this diagram here, it kind of goes over how the process works. So we have the pathogen. It first attempts to gain entry into the body. So in order to do that, it has to pass by the first line of defense, which are your mechanical barriers, your skin, and those mucous membranes. Remember, those are in any system that has an opening to the outside, your respiratory, your urinary, your reproductive system. Those are all systems that have pathways to the outside. So they have those mucous membranes to trap any foreign invaders. So once it gets through the first line of defense, then it can go either the second line of defense or third line of defense, depending on its attack. Usually it'll hit those natural killer cells, and those phagocytes, and once it hits those, then it usually goes into the cellular or cell-mediated immune response. But this just kind of gives you an idea of how your immune system works. Okay, so there are a couple things that trigger the third line of defense. At this point, once you have gotten this, the pathogen has gotten this far into the body, it has created antigens that the body can recognize as either self or non-self. And the self antigens are actually antigens that are normally found in your body. So you can see here identifying self. So this is a white blood cell here, and the white blood cell is like, oh, this is a body cell that's in your body and you're okay. So this antibody or this white blood cell knows that this has a good antigen. So this is an antigen that we want in the body, so it's not going to attack. Whereas this, you can see this, it looks like a little bacterium. So this bacterium has this specific antigen on it, and say they even kind of made it like a little dart, so it's kind of bad. And then the white blood cells will see these different antigens that are normally not in the body, and they will then attack those. So we like self antigens. We do not like non-self antigens. You do not want non-self antigens in your body because those are from those foreign invaders. Let me move that a little bit. Okay, so how we sense those, how those white blood cells sense those antigens is through the antibodies that are released, or marker antibodies. Let me say this again. So you have markers on cells, and markers on cells can sense these antigens. So you can see this is a B cell, which is a immune cell, and it has these markers on it where the antigens can attach to decide if it is bad or good. And I'll get into that when I talk about humoral response in a second. And then you also have antibodies, and antibodies are released by immune cells that can sense antigens in the body. So they will sense if they are good or bad. Okay, so then you have haptens. Haptens is a smaller molecule that cannot be itself stimulate an immune response, may combine with a larger molecule, which makes it detectable to the immune system. So this is found in drugs such as penicillin, household and industrial chemicals, and dust particles, and animal dander. So haptens aren't necessarily pathogens. They're different hazardous chemicals that can enter your body. And when they enter your body, they become known as this hapten. And then our body can sense these haptens as something that should not be there, and they can attack with the appropriate response. Usually haptens are tackled with the second line of defense. You usually don't need the third line of defense with this. Okay, so with the, move my face. Okay, so with the lymphocytes that are used during the specific immunity and acquired immunity, you have two types of lymphocytes. You have the T cells and you have the B cells. T cells are used in the cell-mediated immunity or immune response. B cells are specific to the humoral immune response. So these two responses are the two responses that are found to be used during the adaptive or specific immune response. So T cells, they are actually formed in the red bone marrow and then they mature in the thymus gland. Remember the thymus gland? These T cells are going to mature and then thymus gland is done and then it starts to shrink over time. Whereas your B cells, they are created and matured in the red bone marrow. Okay. Primary locations of where the T cells work are in your lymphatic tissues. So we're talking about the vessels, the lymph nodes, the spleen, all the different thymus gland, all the different lymphatic system organs and tissues and vessels and capillaries that you have found that we talked about with the lymphatic system. And B cells are also lymphatic tissues and some circulating blood. So you're going to see T cells more in the circulatory system than you are B cells. Okay, so the cell-mediated immune response with the T cells, that is specific with infected cells. So a cell has been infected by a virus, by a bacteria, whatever it may be, that will solicit the cell-mediated immune response. Think about it, it's cell-mediated, so it's focused on a cell being infected, and that's why it is being utilized. Whereas humoral looks at like specific actual pathogens. So humoral response will physically attack your bacteria, your fungi, your protozoan, your virus. So humoral is more of the direct kill for the pathogen, whereas cell-mediated is more indirect. Okay. All right, so again, humoral response, we're fighting extracellular antigens. So these pathogens are outside of the cell. They have not gotten into a cell yet. And they're just moving through blood and lymph. So they're trying to get to cells, but hopefully a humoral response can get to it before it gets to that point. And these use those B lymphocytes, whereas cell-mediated, it works intracellularly. So it will take cells that have been infected and kill those, okay, or make the appropriate response. So cells destroy cells from within that are infected by the pathogen. So intracellularly for cell-mediated, extracellularly for humoral immune response. Okay, I love this diagram. I actually wanted to create a foldable with this diagram because I like it so much. So you can see here we have humoral up here and cellular, or if you want to just change it, cell-mediated, it's the same thing up here. And this, we have an intracellular microbe. So you can see this is a body cell. And then if you want to label that, that is the body cell. And inside of that, these are little viruses that have basically taken over this body cell. So this body cell is in deep trouble at this point. Whereas humoral, we have all these bacterium, and actually this is all showing bacteria, but any foreign invader, fungi, protozoan, that is not inside of a cell. So extracellular and intracellular. I'm going to focus on humoral for a second. Okay, so with these extracellular, what happens is they enter the body, they enter the bloodstream, and you have B cells. So these B cells secrete antibodies, and these antibodies attack these non-self microbes, and then they either do one of these three things. So they're going to, one, either neutralize it by just disabling it. They're going to solicit the complement proteins to kill it, to basically cause it to explode. Or you're going to bring in some macrophages, natural killer cells, or neutrophils to actually phagocytize. So the thing to get here is these B cells are going to use antibodies in order to kill this extracellular microbe in either one of these three ways. Now, with your cell-mediated, it's over here. So with your cell-mediated, you have the infected cell, and it's going to present an antigen. So basically, the antigen for this would be a part of that virus to a helper T cell. This cell mediate's a little more complicated. So this helper T cell then is going to release this chemical called cytokines, and cytokines are they're like the warning to other cells. So they go to other cells, other T cells, macrophages, natural killer cells, whatever it may be, to solicit the appropriate response. So, and the appropriate response is dependent on what is released. So if you look at cytotoxic T cells, we haven't talked about, they're actually very similar to natural killer cells in that they destroy that cell. They cause it to lyse, essentially. Whereas your macrophages, they're just going to engulf it, kind of like what we did here, and then kill it from within that infected cell, or within that macrophage. So it just depends on what you have, but the cytokines are what going to solicit whatever the response is that needs to be done. Okay? All right. Yeah, I'll move this back down here. Okay. All right. Now, with the specific immune response, you have your primary versus secondary immune response, and this is something this is the coolest part about our immune system. So what I just showed you would be the primary immune response. So you have to have this foreign invader come into the body first. You have to have the B cells create antibodies toward it. You have to have the T cells solicit whatever response needs to happen. And then it can do its attack. And this usually takes several weeks. This takes quite a bit of time. So you can see here we have our first exposure. Let me explain this graph to you first a little bit. I'm going to move that up there. Okay, so we have days after exposure to antigen, and then we have plasma antibody concentration. So the antibodies produced because of this antigen. So at day 0, obviously you're exposed to the antigen, you're exposed to, for example, coronavirus. You're exposed to it, and you slowly, your body starts to create these antibodies to fight it off. And then as you start to fight it off, we're at like day 15 here, then that starts to slow down, but it stays high because you now have produced these antibodies, but you are able to fight it off. So it takes about 15 days to really get the immunity that you need to fight off whatever that foreign invader is. And one thing that's really cool is during this time, as you're creating these antibodies, your body is producing memory B and memory T cells. And these memory cells remember whatever this pathogen was, and then they stay in your body. So that when you go and you are exposed to this pathogen again for the secondary immune response, you have a quicker overtake of this pathogen. So you can see here, I don't know why it doesn't say anything here. But so these are the days after re-exposure, and this is the antibody production. So if you guys have this graph, I would add antibody production in here. So you have day 0 where you're exposed, and see how quick you get the production of antibodies, because you have those memory B and T cells that can quickly take on that pathogen because they remember it and they know what they need to do to fight it off. So really that takes more, like we're sitting at a week instead of 2 weeks to fight it off. And then it remains high for a while. So it Takes less than a week. So secondary immune response, once you've been infected with something the first time, the second time your body knows how to fight it off very quickly. Okay. And one thing that